Hi, welcome to the continuation session of engineering mechanics. In the previous video, we learned about basic laws of vectors and scalars. Let us know about very important force in mechanics, engineering mechanics. That is called as a conservative force. What is conservative force and what is the importance of conservative force, how it is to be useful to calculate various factors in the mechanics, that can be studied in this session. Let us know about what is conservative force. A conservative force is a force done in a moving particle from one point to the another point, such that the force is not depend on the path followed by the particle. Means what? The force is independent of the path and it is depend on only the final and initial position. So whatever the force acts on a particle does not depend on path followed by the particle, only depends on initial and final position of a particle is called as a conservative force. Here we are taking a particle from initial position A to final position B through various paths. Suppose this is a path followed by the particle with represented green color is 1. The path followed by the particle representing the blue is second path. This is path 1, this is path 2. In these two paths, the work done on a particle by the force is independent or not depend on the path. It is depend on initial and initial point A and final point B. So to explain this, consider a particle of mass m is present at the starting point A and the force F bar is acts on the particle A and taken this particle to the final point B along the path 1, this, and the same particle another time is taken along a second path which is represented with blue color along to the point B, and the work done calculated from A to B along path 1 and along path 2. The work done calculated along path 1 is F bar dot dx bar or dr bar ds bar, and this value is calculated by the height. For both the cases, for both paths, height is same. That is why work done is also same. That is so that the net amount of work done on a particle is independent of the path, and so that it is depend on only initial and final positions. Hence we can write the properties of conservative force like this. If a force has the following properties, then it is said to be conservative. When a force is only depend on initial and final positions, then it is called as a conservative force. If any closed path, the work done by the conservative force is 0, because the force work done taking from A to B is path 1 and B to A is path 2, then the net amount of work done is equal, then the net amount of work done is equal, so that force is equal to 0. The work done by conservative force is irreversible, means whatever the work done in from A to B is always equal to work done from B to A. This is called irreversible. And now this force work done is generally written as W is equal to F bar dot ds or dx, and which is equal to 0 for conservative force. And what are the examples of conservative force? There are few examples are there for conservative force: gravitational force, magnetic force, electrostatic force, electrospring force, electric force are the examples for conservative force. Now non-conservative force, frictional force, viscous force, induction force, air resistance force, tension force, normal force. That are some of the examples for non-conservative force. And now showing that the conservative force is equal to the negative gradient of potential energy. Coming to the showing of here we have the conservative force and negative gradient potential energy Fr is equal to minus del U. This derivation is very simple. Consider a particle of mass m which under the force, conservative force Fr moves from initial point R0 to R, where R0 is equal to x0 I plus y0 j plus z0 k. R bar is the position vector at initial point. R is the final position point, and when it is taken from initial point R0 to R, we can write the potential energy created by that force F is given by UR is equal to minus R0 to R F bar dot dr bar. This negative indicating that the force is taken against the movement of the particle, so that it is negatively represented. And now we are taking this dr bar into this side, or differentiating this equation, what you get. Or differentiating this equation with respect to R, du by dr is equal to F. And generally, we can write the component of F along x, then it is Fx. So dou u by dou x is equal to minus Fx, dou u by dou y is equal to minus Fy, dou u by dou z is equal to minus Fz. As you know that dou by dou x, dou by dou y, dou by dou z is used because of the partial differentiations. Means that if you are differentiating with respect to x, y is constant, z is also constant. Like that we are vice versa. So you are taking. Now differentiating this equation, what you are getting, Fx is minus dou u by dou x, Fy is minus dou u by dou y, and Fz is equal to dou u by dou z. But in general, we can write the force F bar is equal to I cap Fx plus j cap Fy plus k cap Fz. I, j are the unit vectors along x, y, z directions. And writing that Fx, x, y, fz is this equation, taking the common u, and what you get, F is equal to this term in bracket I dou by dou x plus j dou by dou y plus k dou by dou z is representing the differential operator del, and so that you can write the del, and F bar is equal to F is equal to minus del u. This is equal to minus grade u, and this is the negative gradient of. So that the conservative force is negative gradient of potential energy, you can go for this derivation, and it is also very important. And from this, if F is equal to conservative force, minus del u grade u is equal to always equal to 0. F dx is equal to 0. Du by dx is equal to 0. So what you are called, du is equal to 0. That is grade u is equal to 0 for a conservative force. Okay. So what is conservative force? How it is to be explained, and how we are showing that conservative force is negative to the gradient potential of energy is the topic, very important. Next, coming to the torque of a particle. When a particle is present at a particular point where the force acts on edges of the particle, so such that the particle comes under the rotation. If any force acts on a particle to create the rotation to the particle, then that force is called as a torque. Here, the moment of force on a special case on a single particle perpendicular to the edge to develop the circular motion or rotatory motion is called torque. So that is why you are taking the particle present at this point. Here you are showing the x, y, z axis, where the position is represented for a particle r bar. R bar is nothing but here. If the momentum is acting like this, the force acts on this particle in this direction. That is, the force acts with the direction of theta to the position vector r bar. Then we can write that this is the r bar and this is the f bar, which are acts with an angle of theta, and the resultant is also a force, torque force. Due to this torque force, the body comes into rotation, and this torque force tau can be written as a cross product of r bar and f bar. That is why we can write tau bar is equal to r bar plus f bar, and the cross product of position vector and force vector to such that the force create the rotation on a particle is called as a torque. And the torque is a vector quantity, and magnitude of torque is as usual, you know that how to calculate modulus of r, modulus of f, sin theta into, and the r is nothing but square root of x square plus y square plus z square, and f is nothing but square root of fx square plus fy square plus fz square, and that is to be calculation of these magnitudes. And this also calculated by means of determinant method, you know that. And now these two quantities are cross product of these two quantities, and the unit of torque. Here the unit for position is meter, unit for force is Newton. You know that Newton meter is the unit for torque, Newton meter. And this R is always perpendicular to the force acts on this one. And this is the torque. Torque also given by dL bar by dt, where L bar is representing the angular momentum. So now we will go to what is angular momentum and how it is to be calculated. This is the position vector r bar, and the momentum vector p bar is always given by F is equal to dp by dt. Rate of change of momentum is equal to the force. Rate of change of momentum is equal to the force means F is nothing but dp by dt. Hence, whatever the direction of F bar, P bar is also in the same direction. And the P bar and R bar is present like this. The P bar is there in the direction of F bar and R bar is there, then the cross product of R bar and P bar, momentum vector, linear momentum vector, will provide that angular to the rotation to the particle. Then that momentum is called as a angular momentum. So the momentum of a particle, such that it has the rotation is called as a angular momentum. So the angular momentum is defined as L bar is equal to R bar cross P bar, and it is magnitude is given by modulus of R, modulus of P sin theta. This is the magnitude. Also we can write L bar is equal to R bar cross P bar, similar to the torque. So torque and angular momentum both are similarly present on a particle. When the particle comes into the rotation, then these two quantities are developed. This is called torque and momentum. In the next session, we will learn about what is frame of references, what are the types of frame of references, and how it is to be calculated various factors in the inertial and non-inertial frame of references. Thank you and welcome to the engineering mechanics continuation classes. What you are studied in this topic? You are studied conservative force and properties of conservative force, derivation of del, F is equal to minus del U, U is equal to minus del U, and the next one is torque and angular momentum of a particle. Thank you.